Hi, my name's Seth Coleman from Datalogic, here to talk today about the Matrix 300 and give a brief product introduction. Now briefly, the Matrix 300 at a glance is a small barcode reading camera designed for high performance on direct part mark or DPM and poor quality codes. Maximum flexibility with a small form factor was taken into account in the design of this device, and we'll see more about that in a little bit. And it has an electronic focus control via liquid lens, which is the first time we've had this technology for the Matrix series. It's an industrial grade device with industrial IP protection ratings, and we have embedded Ethernet with a power over Ethernet option available as well. Now the image saving and management functionality we'll talk about a little bit as well. It gives you a lot of the power of your imager type devices. So, performance benchmarks. Outstanding performance, a 1280 by 1024 sensor, which is 1.3 megapixels. The sensor is a little different, and the frame grabbing is a little different than our previous 1.3 megapixel camera, and we've got 60 frames a second out of this camera, which is a lot of data throughput. Next generation data throughput. The processing power, 660 megahertz Texas Instruments processor. It's the same processor we used in the 410 series cameras. Very aggressive reading on DPM, on high-speed applications, and on poor quality codes. Now overall form factor, smaller than a credit card. We see the overall dimensions here, 54 millimeters wide by 43 millimeters thick, 75 millimeters tall. Now the minimum height in the critical dimension is our optical axis. So from the front of the camera to the back of the camera, we're only 43 millimeters. This allows us to fit into a lot of our industrial applications with very tight spacing, such as inside of machines and things of that nature. Again, we can see here the mechanical flexibility. We have rotating connectors on the tail of the device. These rotating connectors allow the cabling to either come out of the bottom or the back of the device for our different mounting options. Again, mechanical flexibility, showing here with our electronic variable focus and our rotating connectors, we have a variety of mounting options. The green spot, this is a feature that comes originally from our handheld devices and came through the Matrix 400 and 410 series, as well as in the 200 and 210. Now the green spot is a visual feedback indicator of a good read. Most beepers are almost essentially useless in industrial environments. You can't hear them, you've got over noise overall from other applications and other devices in the area, and so the green spot gives you instant visual feedback of what's happening. It allows you, especially when you have multiple devices multiplexed together, to see which device read very easily and quickly. This green spot is software controlled, and normally we fire it on good read, but we can actually fire it with external commands, and we can also fire it based off of different events. The powerful embedded lighting on the Matrix 300 is using the full face of the device. So because we have the larger frontal area of the device, we can pack many LEDs in there. We have different illumination options available. With the extra illumination, we can have faster shutter and acquisition speeds, more contrast on poor codes, and it also allows us to have a nice wide scanning area. So the image quality with DPM, we have a multi-pattern illuminator. This illuminator has 8 individual zones with 1, 2, 3, 4, 5, 6, 7, 8 zones with both bright field and dark field illumination built into the same package. The ability to control this with software means we can make this camera very versatile, and so we can attack different applications in different ways. The challenge in DPM is almost always lighting, and lighting is the solution for a lot of these applications. It will make or break many applications. And so having the integrated illuminator with everything on board and every option we need on board makes it very effective as an external illuminator without the worries of alignment, power, strobing, and all the other challenges you have. We can see here, these are with standard illumination. Now if we go through and adjust our zones, we can quickly create either bright field or dark field situations by just controlling the lighting zones. Here we have a quick video of embedded lighting for our DPM applications. Here we have a processor with a 3 mil code on board, 3 mil code with an element size about the thickness of a piece of paper, very small code. And right now, with our central illumination, if we change to a different illumination option, we can see here with the embedded low angle, now we have a good read, and we'll zoom in and take a look. Now we have plenty of contrast. Are able to read these very small codes on this processor. Here we have low contrast data matrix on a brushed stainless steel part. This is a laser marked part. We see here we have no contrast essentially. By changing the illumination zones again and making a couple of tweaks, using the embedded low angle, now we can see we're lighting the pocket in that DPM, giving us nice dark field illumination. And there we go, good reads. Controlling the light direction, we have an application here where the part comes in and we have a specific reflection angle. We have very low contrast. If we zoom in here and take a look, we have a difficult time discerning the background from the code itself. And so by simply changing the direction of the light and which illuminator sections we're firing, now we have excellent contrast and a very good readability. All right, our advanced DPM decoding libraries. These libraries have grown and changed with the Matrix series over many years. And so now we have the ability to read more things than we ever could before with our embedded lighting, our embedded light field and dark field. Now we have the ability to read many of these different types of applications. And you know, the Matrix series has been around for many years, and we've grown and adapted these libraries over the years. So the device becomes more powerful with every generation. The Data Matrix Setup Wizard is a way for the camera to automatically go through a calibration procedure which normally would take many iterations of testing and experimentation by a technician. It takes a lot of the art and time-consuming testing process out of calibration and now makes it much more of a science. And so here's a video in which we show this Data Matrix DPM wizard. You can see we have a DPM part here. We go into the Data Matrix Setup Wizard and we can set our image processing timeout. So we're going to set it for 300 milliseconds for this application. And we're going to do some image acquisition and capture. Now we're going to capture 3 different scenarios with codes in different areas of the field of view, things that may happen in the actual application, and we're going to add them to the image database. Now we're doing the auto learn function, and the camera is going through and tweaking the calibration and testing this calibration on all these different image acquisitions. Now it's created a test profile, and it's created a data set, and a full configuration. So now we have perfect reading in any of our given testing scenarios. And the good reads just streaming by. Another difficult application, ANSI grade F corrugate codes. Black on corrugate, sometimes called craft codes. These codes are usually printed on the fly with a spray jet as they go down a conveyor. Poor edge modulation, poor contrast. Not very good codes, and we'll see here with the Matrix series cameras, we have no problem reading them at all. So our focal length options, we have a 9mm liquid lens available immediately and a 16mm liquid lens available towards the end of the year. Some reading charts. We have a wide angle option available with a 6mm lens. This wide angle fixed focus 6mm lens allows us to have a very large field of view at a very close distance. This is particularly good for applications inside of machines, for pharmaceuticals and electronics manufacture. So electronic focus control on a liquid lens. I've said that a few times. What does that actually mean and how does it work? So a liquid lens is created by filling a cavity with a water and an oil solution. Generally, it's an insulating fluid. Inside, there's a hydrophobic coating and an insulator and a conductor that run around the outside edge. Now, we use a physics concept called electrowetting. And it's a similar concept to if you take a balloon and rub it on your hair and then hold it in your water coming out of a faucet, you will actually see the water curve. And this is because of a force from the electrostatic buildup. We can do something very similar here. We pass current through the conductor on the outside of the lens. We can actually cause the water in the lens to react, and we can create a convex, a flat, or a concave lens. And so very easily, very quickly, with no moving parts, we have a lens that reacts to current change. Now this allows us to have a focal position that's a configuration parameter, and we have one spare part for different applications throughout the plant. So we can put a device in, send a configuration to it, and now it's focused at the correct distance. No worry about manual focus and things of that nature. So the electronics focus control allows us to make it extremely easy to set up. There's actually an automatic focus setup within the setup wizard. We can configure it manually if we want as well. We also have multi-focus setup for different reading distances. And so an adaptive setup, if we have a production run and we're changing, say, on a canning line from reading cans to bottles to jugs, and we have a varying distance, now we don't have to be very far away to have that depth of field. We can create the depth of field by just changing the focus position. The reader placement becomes extremely easy because now we mount it. We can change the focus as a runtime parameter. So we have a camera with onboard Ethernet, and we have the connectivity benefits of Ethernet available on board. So your standard data socket, your TCP socket that we hand data back and forth to the host, is available as both a client or a server. We have the image socket, which we can hand the image off. We have an FTP client, which is very useful because you can set an FTP server up somewhere in the plant on the same network, and this Matrix can go out and dump its images off. Now, whether you save all images or good reads or no reads, this becomes useful at the end of a shift or the end of a day. They can review these images and understand what's happening with the camera. If they're saving no read images, they can understand where their no reads come from. And this becomes very powerful for tracking down those last few tenths of a percent of no reads. We have in setting up barcode scanners, it's usually very easy to set a barcode scanner up to read 95%. And then a little bit more difficult to set one up to read 97. And then as you approach that 99 mark, it becomes much more difficult every time. And so if we have the ability to track down those no reads and understand what's happening, we can discern whether or not they're reader calibration issues or operational issues with the actual application. On board is also an HTTP server, so you can log into the camera with a standard web browser and view the images. Here's a visual representation of the HTTP server, and we can see the images there as the carton goes by. No extra tool for visualization, we just need a Java-enabled browser. This is the 6mm option with the manual focus adjustment. No need to unmount any part of the reader, no need to remove the illuminator or remove a cover, we can just adjust it from the side. This is an industrial grade device. It's a full metal housing on the outside here. The connectors are all metal. It's an IP67 rated enclosure, so submersible under 1 meter of water. 0 to 50 degrees centigrade operating temperature. It's ESD safe for electronics environments. We have YAG laser protection as well for mark and read type application. So if we're marking with a laser marker, we don't have to worry about the laser bouncing back in and damaging the image sensor or filtering that out. We have no mechanically moving parts. So as we mentioned before, the liquid lens has no real fixed moving parts, no friction, no cycles. Perfect for harsh industrial environments, resistant to water and dust, resistant to shock, and an exceptional product longevity. 110,000 hours or 12.5 years of continued use on the MTBF. Power over Ethernet is an option. Compatible with market standards. This is useful for machine builders and industrial environments where they're already using power over Ethernet. We don't necessarily need a connection box if we want to use it this way, but we have the ability to connect a connection box if we want those discrete I/O signals to be added to the system. Onboard embedded Profinet will be available Q4. Direct connection to the Profinet network in the PLC. No need for external boxes, no need for external field bus modules. The M12 decoded 4-pin connector, industrial Ethernet standard cabling, is what we use. So this is just a little quick representation of our inter-scanner master-slave connectivity. This is a synchronous IDNet network. Now IDNet is our high-speed communication bus between cameras, between any scanner actually. But here we're showing it between a series of Matrix 300s, and we're using a master and 2 slave devices for multi-sided reading. And so we'll see, as a carton comes in, the master gets a trigger and sends that signal to the slaves. They all read simultaneously and hand their data back to the master. It formats it and hands that off to the host as a single string. Now we're using 3 cameras as though they're one, and we're only having to handle 1 data string back to the master system. Here's an asynchronous system or multi-data IDNet network. Same hardware configuration, just a quick software parameter change. And now, as objects come in to each device, they're triggered individually and they send the data back to the host through the IDNet network, which sends it off to the host system, generally with an address prefix to let it know which device it came from. This allows you to multiplex the system together and have one data communication point back to your host system, whether it's a PC or a PLC. And now we only have to manage one single data set. Here's some 1D reading. We'll see here some of those craft codes. ANSI grade F codes, black on corrugate, poor contrast, poor edge modulation. We see our green spot flashing away as we get good reads. And here's some image grabs. And we'll also see a virtualization or a visualization of the HTTP server as well. 60 frames a second, we see real-time HTTP server. Another speed-related video. Linear code, 2 mm tall. Picket fence and stepladder orientation on the drum. And we turn the speed up. Still reading at 5 meters a second. About 1,000, little over 1,000 feet a minute. And we see images from the HTTP server there. So some of our target markets for this device. Electronics industry, we've already seen some demos of this. Direct part mark on printed circuit boards, components, and housings. The factors for these applications, it's very easy to mechanically integrate this device. Top industrial grade. Large variety of substrates, materials, and backgrounds thanks to our integrated lighting solutions. Very high density code capability. Automotive industry, direct part mark on metal and plastics. Prompt and stable reading, fast responsive device, IP67 again, flexible reading distance, and it's electronically controlled so we can tweak it. Packaging industry, for pharma, food, and consumer goods, 1D or 2D codes, generally at very high speeds in these applications. Winning factors for this, very high performance device, very responsive, image acquisition at 60 frames a second with a very high decoding speed. No need for external illuminators. White lighting available for colored codes and strange colored backgrounds. Onboard image saving for no-read diagnostics. And the plastic cover gives us food industry compliance. Document handling applications. Many times we're asked to cover a very large field of view, a full letter size or A4 sheet of paper or larger. Image acquisition at 60 frames a second with high decoding speeds. And again, no need for external illumination to reach those speeds. We have plenty of light. Onboard image saving for no-read post-analysis as well to understand where our no-reads are coming from. Are they printing issues? Are they material handling issues? Are they operational issues? The automated warehouse, end-of-line carton traceability, and tote identification. The variable focus for dynamic read distance control, and the easy multi-sided systems with our IDNet clustering. Unbeatable mechanical fit between conveyors with our 90-degree optics. And the fact that we have a wide field of view, we can get very close to the device. So again, in review, Matrix 300, high performance for direct part mark and poor quality codes, maximum flexibility with a small form factor. We have electronic focus control with a liquid lens, industrial grade IP67 camera, our embedded Ethernet with power over Ethernet option, and powerful image saving and management.